Hello guys, good evening everyone. Hello Banu Prakash, good evening. How are you all? कैसे हैं बच्चे लोग? This is your KP sir Krishna Prakash. So we are going to start the session. Good evening Ram Prasad, good evening Manoj, Namaskar, good day. कैसा है आप? Good day. Good evening Ramakrishna. So, new batch of open channel flow is going to start from 7th onwards, not 8th. From 7th onwards, December 7th, Monday onwards. December 7th, Monday onwards, new batch of open channel flow is going to start from Monday. So join as early as possible, plus subscription. Okay. Lunch हो गया बानो. Good evening Sai Tejasvi. Good evening Shubhan Shah. I'm good. Good day. Unacademy Combat. You know about it. Already yesterday we discussed the tough questions from GATE examination. The top faculty of Unacademy prepared the most complicated questions for GATE examination. So in that 15 questions for 1 hour, you understand, 15 questions given for 1 hour means how much typical questions we are going to frame. So write this test on December 13, enroll now itself. Enroll now itself. The invitation code is KP Civil. Invitation code is KP Civil. I want my students to crack this because they are having exciting prizes now. Apple MacBook, which costs very high. Apple iPad mini. And the top 100 rankers will get 1000 rupees Amazon worth vouchers. Learning Hindi. Very good, Banu, learning Hindi. So, everyone write this December 13 Unacademy Combat Test Series. And while you are going to enroll or register for the exam, it will ask the code. You know code. I don't want to tell anything. You know code very well. Code is KPCL. So complete the exam, crack it, conquer it, gain the prizes. Gain the prizes. Prize. You are getting free exam you are writing and you are getting good prizes. So worthy prizes are provided by Unacademy. And the 6th December UPPSC AE online mock test is there. Those who are UPPSC AE aspirants, because 13th is the exam. UPPSC AE exam is 13th. 6th December Unacademy is conducting online mock test, All India online mock test for UPPSC AE. Is there any need of web camera during exam? Because I don't have. No, not required, Ramakrishna. No need of web camera for the exam. Don't worry, Ramakrishna. No problem. You can write it directly. Good evening, Srikandan. 25 to 30 marks I obtain in FLT of GATE in spite of all subject completion. For higher marks, good day. Yesterday also I told you. You have my number, I think, already. You just message me. So many sessions I have taken. How to overcome such kind of problems. In Unacademy, so many sessions I have taken, guidance and preparation strategies. So I will guide you, don't worry. But this class, we can't discuss all those things. This is related to subject. Other students are getting irritated. We'll discuss other matters here. Okay. So personally, we'll talk. Mr. Good day. Whatever you want, you message me. Good day. We will talk personally on phone. Okay. Done. So this is the 4th day we are continuing. Free crash course, GATE crash course, concepts on YouTube, problems on Unacademy. So we have completed water quality. Now, water treatment. We are moving towards water treatment. We are going ahead towards water treatment. Generalized treatment order I am writing. Raw water from a river, from a lake, or from any surface source. Raw water or surface water, surface source. First it is undergoing screening. These screens are provided. Where screens are provided? First it is undergoing screening. Where screens are provided? Tell me, Bhanu Prakash. Ramakrishna, where screen is provided? Screens are provided near to intake structure. Bell mouth joint is given at the intake. No, Ramakrishna. Screens are provided near intake or at intake. Bell mouth joints are there now. Screening is provided with bell mouth opening. That is acting as a screen. At the intake, we are providing bell mouth opening. That bell mouth opening of the intake itself has act as a screen. Particles of diameter less than or equal to 3 mm are separated by that screen. Even at the inlet of water treatment unit, if required, one more screen is provided at the inlet of water treatment unit. At source, very good. At source, correct, Ram Prasad. Now, screening followed by primary sedimentation. Primary sedimentation for removal of suspended particles. Screening followed by primary sedimentation. Primary sedimentation is targeted to for what impurity removal? Primary sedimentation for what impurity removal? Suspended solids removal. Suspended solids removal. Primary sedimentation. Correct. Yes. Suspended solids removal, primary sedimentation. Followed by coagulation. Coagulation for what impurity? What impurity is removed in coagulation? For removal of colloids. For colloids. You understand it? Suspended solids are removed through primary sedimentation. Colloidal impurity are fine suspended solids. Very fine. Previous day before yesterday we have written colloids are fine discrete suspended particles. Do you remember it? Correct. Colloids are very fine suspended particles. Yes, Deepanjali, this is the first slide only. Colloids are given very fine suspended particles we are considering. So these are colloids followed by filtration. Again for fine colloids and dissolved solids. Fine colloids, bacteria and dissolved solids. We'll go ahead with the filtration. What we can write down now? Bacteria fine colloids, bacteria, fine colloids, dissolve solids. And last method of treatment, disinfection for pathogenic organisms. Last method of treatment, what we consider? Last method of treatment, what we consider? Disinfection. Disinfection for pathogenic organisms. For pathogens. Pathogens. So this is the order of water treatment. Screening, primary sedimentation, coagulation, filtration, disinfection. 5. You understand? For surface water or river water treatment, 5 treatments. Screening conducted at the source near the intake, followed by water treatment plant, suspended solids through sedimentation, colloids through coagulation, dissolved solids through filtration, and finally pathogens through disinfection. Ramakrishna, tell me what is your doubt, Ramakrishna? We will come for it. Subhan Saab, we are coming for it. Wait 1 minute. Now, this coagulation is a 3-step process. Coagulation involves rapid mixing. Coagulation is a 3-step process. Rapid mixing, gentle mixing, and secondary sedimentation. And secondary sedimentation. You understand, Subhan Saab? Coagulation is classified, differentiated. Coagulation is classified, differentiated into 3 phases. Rapid mixing, gentle mixing, and secondary sedimentation. Okay? What is your doubt, Ramakrishna? You post it. Means primary sedimentation is going to rapid mixing, gentle mixing, secondary sedimentation, and then it was followed towards filtration and disinfection. Filtration and disinfection. Aeration is carried out for well water. Ramakrishna, for well water. Groundwater sample, not for surface source. Not for surface source, will carry out aeration for well water. Groundwater samples. So here now we can classify screening, sedimentation, rapid mixing, gentle mixing, secondary sedimentation, filtration, disinfection. This gentle mixing also called flocculation. Both same. Gentle mixing, flocculation, just alternate words. Gentle mixing or flocculation are alternate words. Clear? This is a surface water treatment. This is a surface water treatment. If you consider subsurface, that is varying. Subsurface water. Treatment for subsurface water, it is varying. Good afternoon, Patil. B. Patil. Good afternoon, very good afternoon. Subsurface water. Subsurface water involves the treatments. Screening is common anywhere. Okay. The intake will always carry the screen, followed by aeration, followed by lime soda softening technique, lime soda softening technique, then filtration, then disinfection. Now your doubt clarified, Ramakrishna? Ramakrishna, you got clarity regarding your doubt. Screening, aeration, softening technique, filtration and disinfection. So instead of primary sedimentation and coagulation, aeration and softening. Sedimentation, coagulation replaced by aeration and softening. That is only difference. Clear? We'll move on now. We'll go ahead. Subsurface water treatment, surface water treatment in a single slide. In one slide, I have provided everything regarding surface water treatment and subsurface water treatment. Now, sedimentation. Sedimentation is also called clarification or settling. Sedimentation is also called clarification or settling. So separation of particles carried out on what forces? Sedimentation is the process of separation of particles. Separation of particles under the influence of, tell me, under the influence of gravity. Only gravity only, no? Gravity only, na? No other, na? Separation of particles under the influence of gravity. Very important. By virtue of, which is playing important role based on self weight and density of particle. Based on self weight and density. Separation of particles under the influence of gravity based on self weight and density. Sedimentation is the process of separation of particles under the influence of gravity by virtue of self weight and density. That is called sedimentation, clarification or settling. That is called sedimentation, clarification or settling. Correct. Mass and density. Mass and density. Very good. Correct. Now, what is the conditions needed for settling? Very important theoretical question. Conditions required for settling. What to satisfy? What to satisfy? What are the conditions required for settling? What to satisfy? Very good. Laminar flow. Very good, Banu Prakash. Laminar flow. VH less than Vs. Laminar flow and VH less than Vs. No, Manoj. Conditions not causing settling is VH greater than Vs. Manoj. Particle is present not settling. That is VH less than Vs. Particle is settling now, Manoj, tell me. Yes, greater than. VH less than VS, VS greater than VH. So what the forces are representing here? Very good. Sahitejas we given, very good. Force of drag. Horizontal flow velocity is imparting force of drag. Settling velocity is under the influence of force of gravity. Drag force less than gravitational force. Drag force less than gravitational force. So while designing a sedimentation tank, you are going to provide a sedimentation chamber. Example, this is a sedimentation chamber you have provided. You are going to provide a sedimentation tank. Water is flowing with a velocity. Water is flowing with a velocity. Water is flowing with a velocity less than particles settling velocity. Correct. Correct. Very good. Ramakrishna, what you said 100% correct. In between we are constructing a baffle wall. This baffle wall is going to control the flow. This baffle wall is going to control the flow. The time taken by the water to travel from inlet to outlet. Time taken by the water to travel from inlet to outlet. This is long when compared with the time taken by the particles to settle down. That is very, very long when compared with the time taken by the particles to settle down. So the target VH less than VS will cause time taken by the particle to settle down is less when compared with the time taken by the water to travel from inlet to outlet. I have simplified. We don't want that much complicated information regarding GATE examination. So I have made it very simplified. Water is traveling 6 hours. Particle is allowed to settle down less than 6 hours. That is enough now. Abdul Basit, V0 is a design. While you are doing design, anything will happen. But practically it should be now. Basit, design criteria you are giving while you are performing design of sedimentation tank, you can assume it. You can assume it. Yes. Okay. But practical condition only responsible for settling. This settling is depending upon practical condition only now. So you have to consider practical flow velocity VH. You need to consider practical flow velocity VH. Clear? No. So very, very important regarding sedimentation is about settling velocity. The most important regarding sedimentation is about settling velocity. VS. Now, this determination of settling velocity is based on diameter of particle. Settling velocity for diameter of the particle less than or equal to 0.1 mm. We are writing the formulas. We are going to write down the formula for settling velocity for diameter of particle between less than or equal to 0.1 mm. Diameter of the particle with less than or equal to 0.1 mm. Laminar flow condition. Laminar flow condition is valid. Stokes law is applicable. Stokes law and laminar flow conditions are valid. Very important this is. Stokes law and laminar flow conditions are valid. Very important this is. for diameter of particle less than or equal to 0.1 mm. Laminar flow condition and Stokes law both are said to be valid. So what can we take? What are the formula we are having? First formula we are considering Vs is equal to GD square by 18 mu. Dynamic viscosity we are taking. So rho P minus rho W. Density of particle minus density of water. Vs is equal to GD square by 18 mu into rho P minus rho W. Density of particle minus density of water. Very good. Kateshwar Barik. After a long time you are coming, Kateshwar Barik. Srikandan. RE less than 1. All those conditions here. Okay, but for our exam that does not helpful. You directly remember particle diameter as well as laminar flow Stokes law valid. Then Vs is equal to same. Instead of dynamic viscosity you take kinematic viscosity. Instead of density you consider specific gravity. Vs is equal to GD square by 18 nu into S minus 1. Clear? Instead of dynamic viscosity you take kinematic viscosity. Instead of densities you consider specific gravity. Stokes limiting condition, that is a derivation here. Derivation depending upon particle diameter. That derivation, Ramakrishna, if you want I will send a link. Complete derivation related to it. For GATE exam you don't want derivations. Already I taught this in YouTube also. Stokes limitations are just Stokes law valid with particle diameter less than or equal to 0.1 mm. Particle diameter increases, flow condition modified. Ramakrishna. Flow deviates. As flow condition modified, Stokes law is not valid. So because of that reason only Stokes law valid between particle less than or equal to 0.1. So here we are taking settling velocity in both cases meter per second. In both cases settling velocity meter per second. Diameter is considered in meters. Diameter is considered in meters. Settling velocity considered in meter per second. Then we have another formula. If there is no information in the data provided regarding viscosity. If there is no information in the data regarding viscosity. Now we are taking Hazen's velocity formula. Now we are going ahead with Hazen's velocity formula. Vs is equal to 418 d square into S minus 1 3t plus 7t by 100. Vs is equal to 418 d square into S minus 1 into 3t plus 7t by 100. Settling velocity of particle Vs is equal to 418 d square into S minus 1 into 3t plus 7t by 100. The most important thing you need to remember here. Diameter you consider in millimeter. Settling velocity you consider in millimeter per second. Settling velocity you consider in millimeter per second. That is important thing. In first two formula, diameter is in meter, settling velocity meter per second. The third formula, diameter in millimeter, settling velocity millimeter per second. So your data provided under what circumstances? Particle diameter less than or equal to 0.1. Blindly use the formula. They will give sometimes detritus tank. They will give sometimes grit chamber. They will give sometimes skimming, whatever the tank it may be. If your particle diameter is less than 0.1 mm and you need settling velocity, blindly close your eyes and solve using the formula. Clear? Don't think too much here. Whatever tank it may be. Velocity is depending upon particle size, not depending upon tank. Remember that point. Velocity is depending upon particle diameter, not on primary sedimentation tank, not on secondary sedimentation tank, not on grit chamber, not on detritus tank, irrespective of it. Yes, correct. Even for air pollution particle settlement also we'll use same formula. Even for air pollution particle settlement also we'll use same formula. Correct. Very good, Banu Prakash. Very good. Okay. We'll move on now. So what is the relation between particle diameter and velocity according to this condition? According to this condition, particle diameter and velocity, Vs is directly proportional to d square. Square of the diameter. Vs is directly proportional to d square. Square of the diameter. Settling velocity directly proportional to d square. Okay. Done. We are going ahead now. We'll move on now. Second condition. Same second condition. What is changing? Diameter is changing. Diameter is changing. Second condition we are writing. Diameter of particle. Diameter of particle. What will take? Between 0.1 to 1 mm. Both values not included. Remember, both values not included. Greater than 0.1 mm, less than 1 mm. Greater than 0.1 and less than 1. Both values not included. Between 0.1 and 1 mm. Clear? Greater than 0.1 and less than 1. Here flow condition is unidentifiable. Flow condition is unidentifiable. You may design the tank for laminar flow. Particle size increases, particle does not fill it as laminar. So as it is not laminar flow, Stokes law not going to be applied. So we don't have any alternate option. We have only Hazen formula. 418D S minus 1 3T plus 70 by 100. 418D into S minus 1 3T plus 70 by 100. Settling velocity, same will consider now. Diameter is taken in millimeter. Settling velocity is considered in millimeter per second. So what you can consider? Stokes law invalid. Stokes law invalid. We can't say exactly. Exactly, it is transitional. For some diameter, it may be transitional. For some diameter, it may be turbulent. For some diameter, it may be laminar. We can't analyze particularly properly for it. So directly we'll consider we reject Stokes law invalid and we are taking 418D into S minus 1 into 3T plus 70 by 100. Now what is the relationship? Settling velocity directly proportional to diameter. Settling velocity directly proportional to diameter. Is there any doubt regarding it? For particle diameter between 0.1 to 1 mm, settling velocity directly proportional to diameter. Clear? We'll move on now. Third condition. For diameter of particle greater than or equal to 1 mm. For diameter of particle greater than or equal to 1 mm. 100% temperature and viscosity inversely proportional. Na? Temperature of water inversely proportional to viscosity. You understand, Ramakrishna? So viscosity is inversely proportional to settling velocity. So what is the relation between temperature of water and settling velocity? Now what we can take temperature of water and settling velocity directly. We'll take this only now. Temperature of water and settling velocity, we'll consider that only now. Temperature is directly proportional to settling velocity. Clear? So for diameter of particle greater than or equal to 1 mm, now turbulent flow is considered. All particles are experiencing turbulent flow. Stokes' law is taken valid. Vs is equal to 1.8 under the root GD into S minus 1. Turbulent flow condition is considered. Stokes' law is valid. Vs is equal to 1.8 under the root GD into S minus 1. Diameter is in meter. Settling velocity in meter per second. We are going ahead. So what is the relationship here? Vs directly proportional to root D. Clear? Very good, Pravalika. Very good. We'll move on now. We'll go ahead. Clear for everyone? Shall we move on now? Sedimentation tank design parameters. So first one you know very well. Anytime we will take discharge only. Discharge is equal to population into per capita demand. Then V naught. Overflow velocity, overloading rate, design flow velocity, whatever it may be. V naught, overflow velocity, overloading rate, whatever it may be. V naught is 500 to 750 liter per hour per meter square. 500 to 750 liter per hour per meter square, V naught. As per IS code we are taking. As per IS code we are considering 17 to 12 to 18 meter cube per day per meter square. 12 to 18 meter cube per day per meter square. Discharge is equal to population into per capita demand. Overflow velocity V naught 12 to 18 meter cube per day per meter cube. So this V naught numerically you can calculate. Discharge by surface area. Theoretically you use that formula. But numerically you will consider, you can calculate using. Who is this? Technical Bahu. I I think he is having some mental disorder. Leave him. Barik. I think he is having some mental disorder. Leave him like that. It is a free class only. Don't worry, Mr. Technical Bahu. If you want, you go ahead, or else you leave. Why every time you are coming? Every time you are doing such unnecessary comments and you are doing. I know some people are sending you. I know who is behind you. Mr. Technical Bahu. I know who is behind you. So you do anything, nothing will be happen to me. Whatever you want, you can do. You give dislike also, you can go. No problem. Leave it. Students, leave him. Whatever he will bark like that. Okay. So barking dogs will come. And do like that. Okay. We'll continue our session. So discharge is equal to population into per capita demand. V naught, if you want numerically, Q by SA. Then. But already you have estimated discharge, population into per capita demand. Already you have estimated discharge, population into per capita demand. Theoretical value as from IS code you are having, V naught. As from IS code you are having. So you are taking that. You will get surface area. Discharge by V naught is equal to surface area. Discharge by V naught is equal to surface area. Surface area. So you got it easily. Discharge surface area, you got it. Easily you got it, surface area. Then L is equal to 4B. Length is, this point is very, very, very important to you. How many maximum times length of sedimentation tank is than its width? This point is very important for you. How many maximum times length of sedimentation tank is more than its width? AE, AEE exam, IS exam, GATE exam, most repeated question. The maximum times for which length of sedimentation tank is than its width, 4 times. You remember that. 4 times. Then we'll write down width. Width you can write it down. Width is equal to under the root of surface area by 4. Under the root of surface area by 4. Now we are solving for depth. Correct. A surface area is equal to L into B. From that we derived B is equal to under the root of surface area by 4. Depth is 3.5 to 5 meter. 3.5 to 5 meter. Here in this we are giving sludge zone depth, because we are providing Hooper bottom sludge. Hooper bottom sludge zone depth we are providing 0.8 to 1.2 meter. Freeboard. No, 5 times impossible. It may take 3 times. Good day. Good day. You understand? 5 times is impossible. You may take L is equal to 4B. You may take L is equal to 3B. You may take L is equal to 2B. But not allowed more than 4 times. But not allowed more than 4 times. Freeboard is equal to 0.5 meter. Freeboard is equal to 0.5 meter. So sludge depth is 0.8 to 1.2. Freeboard is 0.5. Overall depth you can take 3.5 to 5 meters. Clear? You got dimensions now? L, B, H. All the 3 dimensions you got here now. Length, width and depth of sedimentation tank, all values you got here. We'll move on now. So remaining formula. Remaining most important formula I am writing here. Remaining formula related to sedimentation tank. Secondum, that is 0.5 only, don't take 0.3 to 0.5. Yes, depth of sedimentation tank is 5 meter. Correct, good day. Depth of sedimentation tank is 5 meter. Efficiency with respect to design. Efficiency with respect to design consideration will take Vs by V0 into 100. Most important question you need to remember here. They will ask you estimate diameter of particle. Estimate diameter of particle, most repeated. Diameter of particle. By giving information about V0. V0 is given. V0 is given. Then efficiency given equal to efficiency into V0. Vs is equal to efficiency into V0. That is equal to, again same, GD square by 18 nu into S minus 1. Vs is equal to Vs is equal to efficiency into V0. That is equal to GD square by 18 nu into S minus 1. Is it clear? I will make it very simple and easy for you. I will make it very simple and easy for you. Completed writing, shall we move on? Completed writing, shall we move on? Now we are taking a direct formula for diameter of particle. Without having any confusion to you, I always made a single direct formulas to you. Vs into 18 nu, Vs into 18 nu divided by G into S minus 1. This is only now. This is only now. If you take this, G into S minus 1 will come into denominator. 18 nu will go to numerator. So D is equal to under the root of. D is equal to under the root of. So if you remember, that work is easy for you. If you remember, this work is easy now. D is equal to Vs into 18 nu by G into S minus 1. Vs into 18 nu by G into S minus 1. Diameter you need in meter. You required to take settling velocity must in meter per second. Easy now? Is it easy or not? I have made it easy now. Very clear. Very clear. Anyone having doubt regarding it? Diameter of particle is equal to under the root of Vs into 18 nu by G into S minus 1. Easily we are going to finish it. Easily we complete it. It's not it? Done. So this is one formula regarding with respect to coming to efficiency. Then second one they will ask about. Second one they are going to ask you volume of circular sedimentation tank. Circular primary sedimentation tank. We are not going to consider volume of circular primary sedimentation tank. Your comments are not coming here. I think some problem in the system. Okay, your comments are not coming. If you want anything, you just WhatsApp me. I will go ahead with the class. Okay. Volume of circular primary sedimentation tank. D square into 0.011D plus 0.785H. Volume of circular primary sedimentation tank. Volume of circular primary sedimentation tank. D square into special formula, specially designed for circular PST. Diameter in meter, depth, flow depth of water in meter. So finally you are getting volume in meter cube. Clear? Diameter of the tank. Tank diameter we are considering. Tank diameter we are considering. H is equal to flow depth of water. H is taken, small h is taken, flow depth of water. So I am again saying your comments are not visible here. Okay, if you want anything, you give me WhatsApp message. Some problem in the system, I think so. Your comments are not coming. If you have anything, if you want anything, you WhatsApp. Okay, done. We are moving ahead now with respect to now third one. Detention time, which is volume by discharge, and theoretically it is considered as 4 to 8 hours. Detention time, volume by discharge, time taken by the water to travel from inlet to outlet. Design time. Design or theoretical time for water to travel from inlet to outlet. Detention time, volume by discharge. Flow through period. Flow through period. FTP. Practical or actual time taken by water. Practical or actual time taken by water to travel from inlet to outlet. Means while you are designing, whatever time you are considering, that is detention time. While tank is constructed, treatment is going on, water is moving practically from inlet to outlet. That time taken, flow through period, L by VH. Distance by velocity. Distance by velocity, general formula. You know it now. Water is flowing from inlet to outlet. What distance it is traveling? Length of sedimentation tank. With what velocity it is traveling? With velocity of flow VH. Flow through period. Then settling period. Time taken by the particle to settle down. Water time is flow through period. Particle time is settling period. TS. Time taken by the particle to settle down. H by Vs. Time taken by the particle to settle down. H by Vs. So for our exam point of view, very important, you assume, consider, assume L by VH is equal to H by Vs. 4 parameters are there. Na? Length of the chamber, horizontal flow velocity, depth of the chamber, settling velocity. Out of the 4, 3 given to you in the data, 4th one you need to determine. Three parameters provided to you in the data. Fourth one you have to derive. So L by VH is equal to H by Vs. You need to remember that. We have one more type of efficiency here. Remember this carefully. Practical efficiency. That practical efficiency called displacement efficiency. Displacement efficiency is equal to flow through period by detention time into 100. Flow through period by detention time into 100. That is displacement efficiency. FTP by dt into 100. FTP by dt into 100. Flow through period by detention time into 100. Displacement efficiency. The last formula related to sedimentation time. Wear loading rate. Wear loading rate. WLR. Wear loading rate WLR. Discharge by length of the wear. Discharge by length of the wear. Wear loading rate, discharge by length of the wear. Meanwhile, detention time is a theoretical time, flow through period is a practical time of water, settling period is a practical time for settling of particle. Over. Again, equalizing flow through period. This is FTP only. Na? Flow through period is equal to settling time. Equalizing it, we are getting. FTP is equal to TS, we are getting. Among this, we have practical velocity, na? Flow through velocity. Horizontal flow velocity. Horizontal flow velocity or flow through velocity, VH. Practical flow velocity of water. Practical flow velocity of water. Discharge by cross-sectional area. Remember this carefully. Q by BH. Q by BH. It is not a discharge by surface area. Discharge by cross-sectional area. Water velocity, flow through velocity, horizontal flow velocity, whatever the words. Discharge by cross-sectional area. Tank velocity, design velocity, overflow velocity, V0. Discharge by surface area, V0. You understand difference? V0 is Q by LB. VH is Q by BH. So while solving the question, you clearly understand whether the question is about VH or question is about V0. Based on that, you go through solving the question. Okay. So we'll continue tomorrow. Sedimentation is completed today. We'll continue tomorrow. Tomorrow we have a special class bonanza. 4 free sessions. Morning 9 AM to 10:30. Representation of rainfall data, precipitation data. Morning 9 AM to 10:30. Hyetograph, DAD curve, IFD curve and problems related to it, numericals related to it. 11 AM to 12. UPPSC AE, 13th exam is there now, 1 week time. What to do and what not to do within this 1 week. How you have to spend the time in the 1 week for UPPSC AE at 11 AM. 4 PM, this class continuation will continue, YouTube session. Our YouTube session will continue. 8 PM, problems on quality of water. Will continue now. Today one session is there. Today 8 PM one session is there. Tomorrow also will continue problems of quality of water. Tomorrow we are discussing water quality index. Tomorrow we'll discuss water quality index. So most important sessions, all are important topics only for your GATE exam. 9 AM, 4 PM, 8 PM. And those UPPSC AE aspirants. So I will give you the best strategy for 1 week, what to prepare, how to prepare and what to study. Okay. Don't miss the session. If you are not preparing, if your friends are preparing for UPPSC, just inform them. Barik, I think you are preparing for it. You go ahead with it. Okay, I'm going to close the session. So you remember the code KP Civil. Your friends are downloading Unacademy app. First time they are watching the free class. Still now, even though for free class, now Unacademy asking you one code. That code is KP Civil. One and only thing, just spread the word KP Civil. The code is KP Civil. Just spread the code KP Civil. We are starting on 7th, not 8th. On 7th, we are starting full-length course on Open Channel Flow. OCF full-length course, we are going to start from 7th onwards. Okay. We'll meet again at 8 p.m. Today we have the class at 8 p.m. We'll meet again. Sorry for inconvenience. Your comments are not visible to me. Whatever required, you send a message personally to me. You have my number. Because comment box is not working here. Okay. Whatever your doubts related to today's session, you send me WhatsApp. I will explain to you. Okay. Done. Thank you, Anandal. Bye bye, all of you.